may be solid, they may be liquid, they may be the gas, you know. So, so this is directly proportional to the intermolecular force. Intermolecular force is directly proportional to the number of electrons, right? So let's suppose if I give you methane, that is CH4, and ethane, okay, that is C2H6, and C8H 18. Okay. So this would be the gas. This would be the gas. Okay. And this would be the liquid. This would be the liquid. You know why? Because in C8H18, in C8H18, the intermolecular force would be higher, would be stronger. Why? Because it has more electrons. Because it has more electrons. When you have more electrons, so the intermolecular force would be stronger. Particles would become close to each other. So the substance would be liquid. What if you have C15H32? Of course, that's gonna be the solid. Course, that would be solid. You know why? It has more number of electrons as compared to C8H18. So the substance, so the particles would be more closer to each other. So that thing is solid. So that's why I was saying it's not fixed that I can say they are only gases. No, depends upon intermolecular forces of attraction. And the second property of alkane is that the melting and boiling point, right? So again, I would say intermolecular force of attraction is directly proportional to the boiling points, or I can say melting points. Again, the same phenomena, the same strategy. When you have more particles, when you have more atoms, when you have more electrons, so the boiling point would be higher. Let's do a comparison between the two or more molecules. Let's say this is CH4 versus C5H12. This is understood that it would be having more electrons. More electrons. How many electrons? Carbon has 6. The proton number for carbon is 6, and the total hydrogens are 4. 6 plus 4 is equal to 10 electrons. And if you talk about C5H12, it has, sorry, less electrons. Okay. It has less electrons, right, as compared to the C5H12. Now we can count this one. We can count the number of electrons of C5H12. Okay, that's gonna be the, I can say, C5, 6 into 5 plus 1 into 12. So what's the total? What's the total? So it would be 42 electrons. Oh, when the number of electrons are higher, so means the intermolecular force is higher. When the intermolecular force is higher, so the boiling point is higher. So I can say C5H12 has higher boiling point and CH4 has lower boiling point. That's why. Okay. And then, and then, and then, what about the solubility? What about the solubility? Remember, they are completely insoluble in water. You know why? What's the reason? Why they are insoluble? What's the formula for water? What's the formula for water? Hannah? So the formula for water is H2O. Since we know that water is polar, polar means it has charges. Polar means it has charges. Okay. So like dissolves like. Like dissolves like. Polar will dissolve in polar. Non-polar will dissolve in non-polar. But if you have polar and non-polar, they would not dissolve in each other. Let's suppose you have oil. Oil is insoluble. Why? Oil is non-polar. Water is polar. They have a different nature. They have a different nature. They are insoluble in each other. Simple, simple, simple. So alkanes, like I can say, alkanes are non-polar, or the water is polar. They have a different nature. That's the reason they are insoluble in water. But they are soluble in organic solvents. But soluble in organic solvents. You know why? You know why? What's the organic solvent? The organic solvent is hexane, propanone. These are organic solvents. Since the nature is the same, organic solvent is non-polar. Alkanes are non-polar. They have the same nature. They would be dissolving in each other. That's the phenomena. So whenever you are talking about the solubility, then you have to see, okay, what's the nature of each and every compound. If the natures are matching with each other, so they are completely soluble in each other. If the nature is not the same, तो फिर वो insoluble होगा. That's the main point. Okay. Or the volatility. What about the volatility? You know what is this? You know what is this? When the substance evaporates at room temperature. Let's suppose if you have a bottle of, like, let's suppose you have a perfume, and let's suppose I'm going to break it down. So then what you would see in few minutes or a few seconds, the whole content of that bottle would evaporate. Why? Because there is an alcohol, and alcohols are highly volatile. Same goes with petrol. है ना? Petrol is also volatile in nature. They are going to evaporate without any external heat, without any external things, without any external force. They will evaporate by their own. Why? Because they are volatile. You know why? Why? Because the weaker force of attraction. If there is a weaker force of attraction, if there is a weaker force of attraction, so the things will volatile. But if there is a stronger force of attraction, the substance will not be having the volatile nature. Less volatile, I can say. Okay. So, um, IMF is directly proportional, is inversely proportional to the volatility. Is inversely proportional to the volatility. You know why? You know why? कि होता ये है इसमें कि IMF अगर ज्यादा है, IMF अगर ज्यादा है, सो वो कम वोलेटाइल है. क्योंकि देखो, फोर्स ऑफ अट्रैक्शन ज्यादा है ना, सो मीन्स वो कम वोलेटाइल होगा, इवेपोरेट जल्दी नहीं होगा. बट इफ द इंटरमोलिक्यूलर फोर्स इज लोअर, so it would be more volatile, है ना? It would evaporate easily. So they are inversely proportional to each other. These are the physical properties that we have to like consider. Okay. तो सारा का सारा गेम इंटरमोलिक्यूलर फोर्स पे आके अटक जाता है. तो आपको बस थोड़ी सी यहाँ पर मेहनत करनी है ऑन इंटरमोलिक्यूलर फोर्सेस ऑफ अट्रैक्शन. ओके. अच्छा, एक चीज और अबाउट द मेल्टिंग एंड बॉइलिंग पॉइंट्स आई फॉरगॉट टू टेल यू के, अच्छा इसमें ना एक और चीज है, मैं आपको बता दूं जरा कि लेट्स सपोज आई हैव CH3, CH2, 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 CH3. How many carbons? One, two, three, four, five, six. So one, two, three, four, then five, and then 6. Number of atoms are same. बल्कि मैं एक और काम ये करता हूं कि मैं इसको और करके श्रिंक करके मैं आपको बताता हूं कि यहाँ पर चल क्या रहा है. ओके, तो अगर आप इसको देखो तो this is also the CH3 and this is the CH3, right? Uh, it has it has a higher surface area and it has a lower surface area, isn't it? It has a lower surface area. Has a lower surface area. Okay. When you have a higher surface area, so we can say the boiling point is higher, means intermolecular force is stronger, and ultimately the boiling point is higher. But for this one, the intermolecular force is weaker. When the intermolecular force is weaker, so the boiling point is lower. That's it. Simple. Okay. तो ये दो चीजें आपने you have to take care it. Number one is the surface area. Number two is the number of electrons. Simple. Okay. So we have only two factors. सही है जी? Only two factors. Surface area and the number of electrons. Whenever you are talking about the boiling point, whenever you are talking about the melting point, whenever you are talking about the you can say volatility, okay, or I can say when you are talking about the states. More carbons, stronger attraction. That would be the solid. Lower carbon, less number of electrons, weak intermolecular force. So the thing would be gas. These are the key points, okay? So then we are moving on to the chemical properties of an alkane, okay? Since I told you that they are unreactive, you know why they are unreactive? Because they have a single bond. When they have a single bond is a sigma bond is a stronger bond. If examiner asks why the sigma bond is stronger, if you remember, we discussed in chemical bonding if you can see over there, let me show you the diagram for the sigma bond, how the sigma bond is formed. As you can see, the two orbitals are coming closer to each other in such a way that they are going to collide head to head, head to head, head to head. You know, when the two car has a collision, head to head collision, head to head accident, there would be more damage. There would be more penetration. It would be very difficult to separate the two cars. You know why? Because they would penetrate into each other. Maximum penetration due to the stronger collision. Same goes with the orbitals. When the orbitals are joining together by head to head, so the overlapping would be maximum. When the overlapping would be maximum, it would be difficult to separate. Okay. So in HCl, this is a single bond. This is the sigma bond. And sigma bond means the head-to-head overlapping between the hydrogen and chlorine. So this would be stronger bond. More energy is required to break the bond of HCl. Why? This is the sigma bond. Now, if you are thinking, sir, how can we identify what's the sigma bond? So remember, it's very easy. It's very easy. If you can see the single bond, that would be always the sigma bond. Like let's suppose this is C2H6. C2H6. How many sigma bonds? One, two, three, four, five, six, seven. Seven sigma bonds. All bonds are stronger when you can see the double bond. So we will discuss in alkenes. I don't want to discuss the pi bond over there. We are only discussing the single covalent bond that is stronger. Okay, so the first chemical property for the alkane is combustion reaction. I think so. This is an old reaction you have also already studied in your previous classes. But of course, this is in our syllabus, so we have to discuss it. This is mandatory. But this is very easy, of course. Before going to do combustion reaction, hopefully the combustion reaction is always an exothermic reaction. Always the energy is released. Always the energy is released. So first of all, uh, chemical chemical properties of chemical chemical properties chemical properties of alkanes. Chemical properties of alkanes. So the first chemical property that we will be doing is a combustion reaction. Combustion. What is combustion? What is combustion? Combustion means burning. Hana? Combustion means burning. Combustion means burning. Burning of anything. Burning of anything. Okay? Burning of anything. And whenever the things burn, so they burn in the presence of oxygen, isn't it? Whenever the things burn, they always burn in the presence of oxygen. Okay, so oxygen is mandatory in burning. So remember, oxygen is mandatory in burning. If you have an oxygen, so you can combust the substance. If you don't have any oxygen, so you cannot burn the substance. So oxygen is mandatory. Sometime we have more oxygen, excess oxygen. Sometime we have limited supply of oxygen, isn't it? Sometime we have more oxygen, excess amount of oxygen, and sometime we have minimum amount of oxygen. So depends. So it depends. Okay, so there are two types of combustion reaction that we would be discussing. There are two types of combustion: complete combustion and incomplete combustion. Okay, complete combustion and incomplete combustion. So what is complete combustion? In which there is a plenty supply of oxygen. And what is incomplete combustion? In which there is a minimum amount of oxygen. It matters. It matters a lot. In the presence of excess amount of oxygen, the product would be different. In the presence of limited supply of oxygen, the product would be different. And if you have a least supply of oxygen, so the product would be different in fact. Okay, let me tell you each and every case. So first of all, combustion means, combustion means burning. Combustion means that burning, burning in the presence of oxygen. In the presence of oxygen. Okay. So then we are going to discuss complete combustion. Complete combustion. Complete combustion means we have excess oxygen. And when there is an excess of oxygen, so the products are carbon dioxide and water. Always. This is always. When you have excess oxygen, so the product would be carbon dioxide and water. And you know why I'm saying water? Because we are going to combust alkanes. What are alkanes? Carbon and hydrogen. Let's start from CH4. Let's start from CH4. Methane, ethane, propane, butane, pentane, hexane, heptane, octane. So CH4, CH4, then we have C2H6, then we have C3H8, then we have C4H10, then we have C5H12. सब के सब they are reacting with O2 and they are forming carbon dioxide and water. Okay, they are forming carbon dioxide and water. That would be the same for all. Same, then same, then same, and then same. Now we have to balance this. Now we have to balance this. If you remember, we used to balance it in an easier way. The number of carbons are equal to the carbon dioxide, and the number of hydrogens are equal to half of water. Look at this. Look at this. One carbon, one CO2, four hydrogens, two water, two carbon, two CO2, six hydrogens, three water, three carbon, three CO2, eight hydrogens, four water, four carbon, four CO2, 10 hydrogen, five water, five carbon, five CO2, 12 hydrogen, six water. You know, this is the trend. Carbon is equal to carbon dioxide. Hydrogen is equal to the half of the water. Now you have to balance oxygen. Now you have to balance oxygen. How we are supposed to balance oxygen? So two oxygen and two oxygen, total four oxygen. So I am supposed to write two so that it would become two into two is four. This is balanced. Then two twos are four. Three ones are three. Three plus four is seven oxygen. How many oxygens we have in the reactant side? Two oxygen. What I'm supposed to write to make it seven? What I'm supposed to write to make it 7? 7 by 2. How? 2, 2 cancels. The remaining answer would be 7. So 7 oxygen, they are balanced. Okay. 3 twos are 6, 4 ones are 4. 6 plus 4 is equal to 10. So we need 10 oxygen. How many oxygens we have right now in the reactant side? 2. I'm supposed to write 5. This is balanced. Then 4 into 2 is 8. Then plus 5 ones are 5. That is 13. How many oxygens we have? 2. So I am supposed to write 13 by 2. 2 2 cancels. The remaining one is 13, isn't it? Then 5 twos are 10, 6 ones are 6, total is 16. How many we have? 2. So I'm supposed to write 8. 8 twos are 16. So now the equations are balanced. This is all about the combustion reaction. This is all about the combustion reaction. Easy है, मतलब इसमें कोई as such कोई वो नहीं है, मतलब आपको इसी तरह से बैलेंस करना है. सही है जी. अच्छा, अब आ जाओ. Let's move on to the incomplete combustion. Incomplete combustion. What is incomplete combustion? Limited supply of oxygen. You know, it's not right now. This is a plentiful supply of oxygen. Okay, plenty of oxygen. लेकिन incomplete combustion में क्या होगा? In incomplete combustion, limited supply of oxygen. And the product is carbon monoxide and water, or carbon solid and water. Carbon कब बनेगा? When you have least, when we have least supply of oxygen. That's it. Okay. All the things are same. All the things are same, but the products are different. Product क्या होगी? Let's change this. CO, 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 CO. Monoxide, monoxide, monoxide. Only the oxygens are gonna change. So it wouldn't be two. It wouldn't be this. It wouldn't be. That's it. Now we have to balance oxygen 1 and 2. 3. So 3 by 2. 2 and 3, 5. 5 by 2. 3 and 4, 7 by 2. 4 and 5, 9 by 2. 5 and 6, 11 by 2. So इसको देख लो जरा. It's not difficult. I think it's very easy. It's an old topic. Nothing is new. यहाँ तक किसी को भी प्रॉब्लम हो रही है तो feel free to discuss with me.
No, sir.
सेट है सब ओके हो गया गुड हो गया. अच्छा जी. ओके ओके ओके. Then we have the second chemical property, that is free radical substitution reaction. This is the second chemical property, free radical substitution reaction. It's also known as photochemical reaction because this reaction occur in the presence of sunlight. This reaction occurs in the presence of sunlight. If you have a sunlight, so you will see a product. If you don't have a sunlight, so you won't see any type of product. It depends upon the, you can say, presence of sunlight. Okay. Acha ji. So, so first of all, we have halogenation. It's a type of free radical substitution reaction. In halogenation, what we are supposed to do, what we are going to do, uh, the hydrocarbon, that is an alkane in this case, would be reacting with halogen. It may be chlorine, it may be bromine. Only we have two cases. There would be chlorine, there would be bromine. We have two cases, okay? Chlorination and bromination. So let's see, first of all, chlorination. Hydrogen is substituted by chlorine. Hydrogen is substituted by chlorine. Okay. तो कैसे कैसे कैसे? Let's suppose I took CH4, it reacted with Cl2 and it formed this and this. तो गौर से देखो अगर तो तीन चार हाइड्रोजन थे यहाँ तीन हो गए. Where is the fourth one? Where is the fourth one? तो वो जो fourth one वाला हाइड्रोजन था, it is substituted by the chlorine. It is substituted by the chlorine. Okay, it is substituted by the chlorine. Or since we have two chlorines, so one remaining chlorine would be reacting with hydrogen, so it would be forming HCl. It would be forming HCl. That's it. Acha, if we have excess supply of chlorine, then what would be the product? All hydrogens would be substituted by chlorine. That would be giving you CCl4 and then HCl. So, bhai, look at the condition what the examiner has given you. If he is saying that excess amount of chlorine, so yes, all the hydrogens would be substituted by chlorine. Simple. If he's saying, like if he's saying nothing, only the chlorine is there, So then you will be substituting only one hydrogen by chlorine. अदरवाइज वो पता है क्या करता है, आपको बता देगा एक दफा सब्स्टिट्यूशन करनी है, दो दफा करनी है, तीन दफा करनी है, चार दफा करनी है, ही विल बी टेलिंग यू. ओके. अच्छा, basically we have to do a mechanism. Mechanism means how this reaction is gonna happen. First of all, initiation. What is this? The reaction is going to start. The reaction is going to start up. The reaction is going to start. Initiate. The reaction is initiating. Okay. So let's suppose this is the chlorine. This is a covalent bond between the two chlorine atoms, right? Okay. Or or the sunlight is striking on the covalent bonding. So the bond is going to break down just like that. Okay. So they are formed chlorine radicals. What is radical? Radical has unpaired electron. Radical has odd number of electron, and radical is very reactive. Radical has no charge. Radical has odd electrons, and radicals are so much reactive as compared to the number, as compared to the ions. As compared to the ions. Ions have a charge. Radical has no charge. Ions are less reactive. Radicals are more reactive. Ions have even electrons. Radicals have odd electrons. Simple. ओके. तो ये है एक बात. दूसरा ये कि once the reaction has started, once the reaction has initiated, so a lot of chlorine radicals would be formed. You know why? Because एक chlorine थोड़ी है कोई हमारे पास. We have a lot of chlorine molecules. We have a lot of chlorine molecules. बनते जाएंगे radicals, बनते जाएंगे, बनते जाएंगे, बनते. You will see a lot of radicals over there. तो ऑब्वियसली बहुत ज्यादा रिएक्टिव है रेडिकल, तो अल्टीमेटली कोई ना कोई तो इफेक्ट आएगा इसका, है ना. तो ये क्या करेगा, ये एल्केन को रिएक्शन करने पे मजबूर कर देगा. ये एल्केन को रिएक्शन करने पे मजबूर कर देगा. जैसे कि अगर हम आपको कहें कि यार कहीं चलते हैं खाना खाने, आपने कहा यार मूड नहीं हो रहा, भाई मैं बार बार बोलता रहा चलते हैं चलते हैं चलते हैं, तुम भी बोलोगे चलो यार चल ही लेते हैं, दिमाग खा रहा है कब से, चल ही लेते हैं चलो. असल में the thing is कि it's very reactive, or when it would be approaching to the alkane, that is CH4 in this case, so then CH4 will have to react. CH4 will have to react unwillingly or willingly in both cases, because radical is there, because radical is there, right? Because radical is there. If the radical is there, तो फिर तो रिएक्शन होगा हर हाल में, फिर तो रिएक्शन हर हाल में होगा. तो दैट्स द मेन थिंग, दैट्स द मेन थिंग. एक तो ये बात हो गई. अच्छा, number one, and the number two thing is that we have two types of bond breaking fission: homolytic fission and heterolytic fission. Homolytic fission and heterolytic fission. What is homolytic and what is heterolytic? So when you have equal distribution of electron, what do you mean by equal distribution? What do you mean by equal distribution? Basically, this is a covalent bond. These electrons are shared between the two non-metals, of course. So he's taking its electron, he's taking its electron. It's a even distribution of electron. So when the bond is being broken down by the even distribution of electron, so that's called homolytic fission. As a result of homolytic fission, the radicals are produced. अच्छा, बहुत सारे बच्चे पूछते हैं हमें कैसे पता लगेगा that would be homolytic fission or a heterolytic fission. So do you know this is non-polar? Yes, I know this is non-polar. So there would be homolytic fission. You can see the compound is polar. HCl is polar, H2O is polar, HBr is polar, NH3 is polar. So polar में you will see heterolytic fission, but in non-polar you will see homolytic fission. ये बिल्कुल मैंने आपको एक शॉर्टकट सा कॉन्सेप्ट बता दिया. In non-polars there would be homolytic fission. In polars there would be heterolytic fission. Simple, unequal distribution of electron. Ions are formed. Okay. But we are more interested in radicals. We are not interested in ions. Like we're not interested in the heterolytic fission. Right now we have homolytic fission. Right now we have homolytic fission. As a result of the homolytic fission, the ion like the radicals are produced. Like the radicals are produced. Okay. अब ये radical जाएगा और ये आगे reaction करेगा. Okay. अच्छा एक चीज और. I did the half arrow. I made a half arrow. Why? Half means one electron is going. Single-headed arrow used for homolytic fission. Double-headed arrow. The two electrons are going. The pair is going. Double-headed arrow used for heterolytic fission. है ना समटाइम आपने देखा होगा यूं बना रहे होते हैं when you are going यूं so means that the two electrons are moving when you're doing this one the one electron is moving isn't okay that's it simple so homolytic के लिए single headed arrow is used heterolytic के लिए double headed but we are not doing right now we are doing this one so we would be studying this one we are considering this one the single headed arrow okay और यहां पर मैंने इसको समराइज कर दिया एज अ रिजल्ट ऑफ होमोलिटिक फिशन व्हाट वी आर गेटिंग एज अ रिजल्ट ऑफ heterolytic fission what we are getting it's बिल्कुल ही tiny concept okay hopefully you understood these things so we have to do propagation step then how the reaction proceeds like what would be the next product so we will be discussing in the next class